Right, ladies and gentlemen, good morning. Thank you for attending an 8 o'clock lecture on a Friday morning, on a rainy Friday. There are some announcements. The class rep, Miss Daly, has asked me to announce that she will continue with the WhatsApp group that she had last semester, right? So she is giving out her cell phone number to the whole class, which is a very brave thing to do. But I sent all the details in an email. So if you want to join the WhatsApp group, store her number and then send your cell number to her and she can add you to the WhatsApp group. She sends out, hopefully, only useful information, like remember that, I don't know, venue changes or reminders about assessment dates and so on and so forth. Tips for the tests and so on, okay? So please feel free to join. I did send out the email with all the information and the cell number as well. Okay. Then, venues. From Monday, I would like to move back to the engineering building. Would that be good or bad for you? Who votes for going to the engineering building? Oh, yes, in om te tel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who votes against going to the engineering building? Wat kan ek nou doen? Okay, I have a serious problem now. Half of you want to and the other half don't want to. Okay, let's make this deal. We can stay in this venue except for a Friday morning. Friday mornings is in engineering. Can we do that? Would that be a compromise that's acceptable? But not the other way around. No, Friday mornings engineering, because I have to go to the office by 6:45 to get my parking space and run down here and all sorts of things, okay? So I'm giving the group who wants to stay here 2 lectures in this room, only Friday morning, 8 o'clock. Then I don't have to run through the cold and the rain, whatever. Okay, cool. Is that an acceptable compromise? Comments? Yeah? Vra jy of wys jy? Okay, right. The CS Stoked, for those of you who would like to learn some mobile programming, we started with, tried to start yesterday afternoon, but it turns out that the installation in Argo is not working, right? So I'll follow that up and hopefully by next Thursday it will be up and running. If it's not, we can continue with it, but then you would have to bring your laptop in. Okay, but I'll try to sort out the Android Studio in Narva. Remember that you have to go to Narga H if you want to do CS Stoke, right? So both the people who want to have tutor support as well as the people who want to learn mobile programming go to Narga H. The rest of you are in Narga D. Remember, you have to start with your projects, right? Because it is Wednesday the 10th of August, lunchtime, the project has to be in. There will be no demo because you're writing the test on that Thursday afternoon. Okay, but there will be, remember the project continues and you will have a demo when you hand in project 2. So the demo comes with the after you've written the solver as well. Important thing about the project, please, please, please do not run away and start programming. Most of the marks, I'll put up the marking schedule, but most of the marks will go towards your object-oriented design. Yes? So it's not so much that it's working per se, but how did you implement it? Okay? If you get stuck on object-oriented design, you can also ask the demis on a Thursday afternoon for the tutors. Okay? Any questions? Yes?
Are the input files that we're going to use the same as that other university project that we linked to on the project page?
Right, so there are links on the project page. Note that we changed the rules somewhat so that you cannot blankly use that. Meneer Stigling, stuur vir my 'n e-pos dat ek onthou om 'n paar input files op die web te sit vir die projek. Right, so I will put up valid input files so that you can test your, yeah, okay, we'll do. Any other questions? Any other comments? No? Okay, cool. Can we run? Okay, so where are we? We are looking. Okay, yeah. We said on Wednesday that a string is not a primitive type, it is actually a reference type. So when you manipulate strings, you're actually manipulating objects. And then the last example of string processing is the genomics application. And if you just look at the problem statement, if you want to handle it just doing arrays of charge, it's a bowl of spaghetti. But if you do it using the string instance methods that are available, it becomes much easier. So the problem is this, you know, I might be biologically incorrect here and there, right? I did biology 30 years ago, last time. Okay. In DNA, you represent DNA with 4 little letters, A, C, G, and T. And then you just get a long string of these things. Okay? Now, what's very interesting in bioinformatics is search and pattern recognition. Okay, so in bioinformatics, if you go into computer science A in the bioinformatics direction, you look for patterns. And in CS144 next year, we will look at very clever searching algorithms. Okay, so finding patterns in text is one of the things that is really exciting in computer science these days because you find it everywhere. There's simply too much information. What do you do with the information? Well, find patterns. The moment you have the pattern, you call. Incidentally, you might know about Watson, that clever IBM program, yes? And Watson is interesting in the following sense. Watson can predict things. So normally in machine learning, you get lots of data and then you learn the answer to a specific question about that set of data. Yes? So I have lots of data. A human being sits there and asks me a question, and I go through the data. I sort, I learn about this set of data, and then I can answer the question. What Watson does, and what is the current trend in machine learning, is prediction without having a question. So just getting the whole humongous petabytes of data and then search and search and search through that data to find a pattern without somebody having asked a question and then us look for the answer to that question. Okay. So search is very interesting. For those of you who are doing computer science as a major, you might consider getting a better background in statistics. Yes, because a lot of computer science these days is about statistics. Statistics, it's easy, it's just counting. Okay, they'll probably throw me out of the building for saying that. But even things like machine translation, it's just, do you know how Google translates? Currently, Google uses statistical machine translation between languages. There where you say translate.google.com. So what Google has at the moment is they have lots of the documents where you have in a source language and in a target language. And those are translated by hand. And then when you type in a phrase, the Google engine search for that phrase, and then it looks in all the documents that it has for that specific phrase, and then it counts all the different translations that is possible, and it gives you the one that occurs most often. Incidentally, okay. There are of course other ways to do machine translation, but okay, that's what they're doing. How the hell did I get from DNA to machine translation? Okay, strings. So let's searching. It's all about searching in strings. So I don't want to tie myself in a bowl of spaghetti with doing all the string manipulation. So here is a very sweet little program that can find genes within, well, no, it cannot find genes, of course not. Given a textual description, a long string of A, C, T, and G's, it can find strings within that string that represents a gene, right? So what I have to do is I have to say, well, where do I start? That's called a codon, a specific code. So that's where I want to start, and that's where I want to stop. So suppose I want to find a gene that starts with ATG and it ends with TAG. Yes, so that's my start and stop codon. And now I can use string, right? I declare genome as an what? As an object of reference type string, yes. And I read all my data from standard in. And now I can simply use the instance methods available on a reference type string, yes, which is in my API, and I can apply that to genome. So I have start and stop codons of length 3, so I can use the length, and I take a substring from where I am, the next 3 letters, and then I use if codon equals start, that's where I'm beginning, if codon equals stop, and I'm not at the right at the beginning of the string because I don't want to start with the stop codon, right? I can check the validity rule. Yes. Okay. So this is all string manipulations. And this is actually immediately useful. So if you have a fellow student who are doing genetics, this is immediately useful in some of the stuff that they're doing. And it's clear your abstract thinking is about manipulating that object instead of worrying about substrings and stuff. Okay, right. Okay, This is where I want to start. Input and output, good old standard in and standard out and standard raw, are not object-oriented, right? So in this section, we look at input and output as well as raw. And now there are new libraries. Instead of standard in, you get in. Instead of standard out, there's out. Yes. Instead of standard draw, there is just draw. So instead of making a variable, declaring a variable, and then calling static methods from standard in and standard out and standard raw, what I can do is I can make input, output, and draw objects. Yes? And then I can call instance methods that work on those objects. The one, it doesn't sound like a lot of difference, but one of the things that you do get is, of course, now you can have multiple inputs and outputs. Did you do some command line redirection in the first semester? You should have. It's part of the book, piping and so on. But there you have one stream. Suppose I run a Java program from a command line and I say, get my input from this file and write my output to that file. It's one input file and one output file. So it's one input stream, one output stream. If I do it the object-oriented way, I can have multiple. Yes? So, class is redefined, but let's look at examples of why that is useful. For example, suppose I want to concatenate files. Yes. So I can write a little Java program that says, copy all the input. No, it's on the wall, so I cannot clean it. Irritates me. I want to copy a number of input files to an output file. And I want to do it in one go. Yes, with one little program. So what I do is I declare an object out of reference type out. I instantiate it with a new. Now I have an object out. Yes. Then I declare an object in, I instantiate that. For string S, I copy everything in the input file into string S and I print it to out. And I can do that repeatedly for any number of files. Yes? And so then you get something like this. If I have in one.txt, in two.txt, different text files, I can run this little program called cat, and it can take any number of input files and copy it to the output files. After I've run the program, I would get one output file which contains the concatenation of the previous two. But the whole issue here, in other words, is that I have multiple input streams. Okay, which is more difficult for standard draw and standard in and redirection. But what I want to get to, sometimes you have information on websites and you want to check that website repeatedly because the website gets updated. The example in the book is for the price of stocks. You might want to watch a certain deal on Takealot, or anything you can think of where a price might change. So you really, really, really want to buy this thing and you want to watch over a period to see when the price will start falling. Yes, and then decide one day after you get the latest notification, now it's cheap enough and I'm going to buy it. Anything like that. These are all money related, but there are other things that you might want to watch. You might want to watch my.sun to double check when your results come out every 5 minutes because you're sure you failed that one specific subject. Sounds like a sort of a hairy program to write, okay? Not something you feel you can do at the moment, maybe, but here it goes. What you can do is if you look at the website, you know that you can click to see the source of the website. Yes, do you know that? Have you ever done that? Open source, and then it shows you the HTML. Incidentally, how do you make websites? Do you use content managers? Do you use something like WordPress? Or do you write the HTML by hand? What? Who uses content managers? Yeah. Do you know what the problem is with the content manager? Yeah, security. You can get hacked like nothing else. So, I don't want to tell you things that you know, but you know that to make a website, you create a file called an HTML file. Yes. And an HTML file has commands like these. It's got little tags. So everything you do has a tag. So you start your file with a smaller than sign HTML, close it, and in the end, right at the bottom of the page, you have that again, /HTML. That's the beginning and the end blocks. Yes? Are you all bored? Should I just jump? Do you all know this? No. No, not everybody, so be patient. Okay? So, for example, this over here comes from a table. TD is table data. TR is table row. And so on. And then you can say exactly what it should look like. But that is clearly a pain to create a nice looking website looking like that. So what most people do is to use content managers. And what content managers like WordPress or Joomla or all these, there's one behind every bush. What they do though, is they have JavaScript commands at the top of every file. JavaScript is a scripting language, so it's Java less the steroids, right? It's a restricted form of Java called JavaScript, and that you can put into your HTML file. For example, suppose I want to put something on my website which requires a password. Only people doing CS144 should have access, so now a little program must run to ask your password, now check my password list and so on. That's a little program that runs inside the web page in JavaScript. The moment you have JavaScript in a website, somebody can hack your website. Somebody can hack your web page. So all these content managers have very strict security protocols. Yes, and you have to keep up to date. It's like Windows, right? There are vulnerabilities and it gets hacked. Okay, so you have to keep up to date. If you don't, people just hack your website. I've been hacked 2 or 3 times, yes, because I asked students to make me a nice website. And then they use, for heaven's sake, these things. Yes?
It's a very long explanation, but just a little bit more elaboration on that. I don't want to do this.
But you should. As a computer science student, you should try to hack. For the ethically, back yourself or a friend. But in a decent way, you have to want to get in, not to do any malicious damage, but to get in, so that you know when you write your own stuff that you can prevent that kind of thing. You see, that's the problem with me. I keep on going off on interesting topics. Please send me an email and I'll put up a nice document on the website on how web pages are hacked. Exactly how you get into that JavaScript. No. Okay, quick answer, because now he's going to wonder for the rest of the period. You get JavaScript that runs programs when you have a dynamic website where you want interaction from the person reading the site. So the moment you want to type in something on a website, you hack it all because you need the JavaScript. The moment it's a dynamic website. And so what people then use are all sorts of variations on, because the website expects me to send them a string, I type in things that will give me information that I shouldn't have if the website is not secure, and then you can get in. So that is where you get in. If you have a totally static website without JavaScript, you're not hackable unless somebody gets the root password of the machine. Okay. But I'll put some more stuff on it. In your honors year, we have a course on security. Right? Okay. Good. Sien maar nou ek raak uit. Okay, hierdie is so lekker. Okay, so what you can do with the knowledge you currently have of within and out, you can do, you're watching stock quotes, you want to know when to sell and when to buy. So what you can do, look what you can do. You can read the name of a website. Yes, your URL. You can read that. Why not? It's just a string. Yes? So I give my website address to in, right? And I read all the text on that website. I can. The source is available. I can read the HTML. That read all returns me a long string of characters, exactly the HTML source code, because the source code for every web page is available. If you can see the web page, you can see the source. And then I assume in this specific example, the thing I'm looking for is on the web page, it says last trade, yes, and a price. So what I need to do is I have to find the text which says last trade. And that I can get because So I have an integer trade and I have an integer from and to, and in is my object. In is a string object containing all the text on the page. So I can try to find in that string the word last trade, and then I can get the substring, and Bob's your uncle, there you have the price. Every time you scrape the website, scraping a website means you read the text. And then you can search for substrings of interest within that string that you got from the website. Okay? I think this is so cool. You should seriously try this. Okay?
One quick question. Create a new in the page. What is the symbol? I want to be very. What's easier?
Well, your phone.
URL.
Yeah. Oh, right. So you see that the little static method called price expects a string. Yes. So the string that it expects is an identifying string that points me to the correct web page. Or the, okay, let me rephrase. If you, this is specific example, right? The web page itself is a page on the website for Yahoo Finance, right? So that specific web page they call Gook for whatever reason. So I might want to do it for something else. So you'll see a website has a lot of different pages. So that symbol argument specifies which page on the website. Yeah. So you'll notice that I simply send the website address and then I specify which page in that on that website by specifying symbol. Oh, great. Right. You see, nou raak ek uit. So please read splitting a file, same kind of thing. Lot of data manipulation. Suppose I have a file like an Excel file that was exported to CSV with different columns, and I want to extract one column from that file. How can I do it? I can use string objects again, right? Draw is the same thing. But now I want to get to this, which are the following 1, 2, 3, 4, 5, 6 pages. Page 352 to 358 is the most important set of pages in this section. That's what comes in the test, right? See, that's my motivator, my carrot. This will be in the test. Properties of reference types, because it's all fine to be able to use objects, but you are computer science students, so not only do you have to be able to use the objects, you have to know how they behave when you use them. Yes. So, properties of reference types. There's a difference between a name and a thing. Yes. For example, in South Africa, there is this ridiculous, absolutely, totally idiotic tradition that when a woman marries, she loses her name. Please don't do that. I kept my maiden name. And I'm happily married. My name is the thing I like. Why should I change it? Okay? So, I have a name and I am me. Now I get married and my name changes. It doesn't mean that I changed. The name changed, but I'm still the same person. Yes? Okay. Exactly the same in programming. All the women are smiling and the men are just looking at me. For the men, do not allow your wives to change their names. It's stupid. Okay. Hold on. There's a thing and there's a name of the thing. Then you're also with human beings. What is nicknames. Nicknames. You get nicknames. People like nicknames. So if I call you on your birth name or on your nickname or on your surname, 3 different names, but the same person. Okay? And it's all associated with you. And I can add other names later if I want to. You meet somebody else and they give you a different nickname. Yes, but it's the same person. The same in Java programming. I have an object. I have the values in memory for that object. There is my object. But I can have different references pointing to that same object. One physical object with values in memory, but I can have different references pointing to it. I can delete one of the references. I can wake up one morning and say, if you call me by that nickname again, I'm going to shoot you. Pacifist. I'm going to be very upset with you. So you never call me by that nickname. So that nickname is gone, but I'm still here with all my properties. Okay, right. So this is not a pipe because it's a picture of a pipe. So let's look at the Java to bring that home. Remember what happens with objects. I have a reference type. I declare a variable of that type. What happens when I declare a variable of that type? I get a space in memory with that name, and there's nothing inside the memory. Yes? Then I instantiate one copy of the object. Then a value is filled in, and down here in the memory, the values are written down. Yes, so now A is cool. Then I can do something strange. I can say color B equals A. So I assign the value A to B. Note that this means simply that I make a new reference, a nickname if you want. I give a different name, and that points to the same value. Okay? The reference points to the same object. This is known as aliasing, because there are two, it's an alias, you know, like criminals do. Also known as. This guy uses the alias blah, blah, blah. So this is aliasing. However, you have to be very careful in manipulating the references. Look at this. Suppose I make a new picture A. Yeah? Then I say picture B equals A. So I assign the value of A to a new reference B. B now also points to the same picture that A points to. If I set the color A.set and I make it a new color, yes, then A changes. This picture manual.jpg will show a change. If I say B.set color, the same object changes. So if you have two references to the same object and you update either one of those via either one of those references, that same object changes. So if you want two copies of that picture, you must write different Java code. You must new again. If you want, for every copy, for every different copy, you have to new. Otherwise, you're just using the references. Yes?
So it's only the case with objects and reference types. So if you do the same thing with, let's say, integers.
Clever question. Yes. What happens with integers? Let's think about it. With primitive types, I do not have a reference. I want to write it out. Bear with me. Let's write the Java. Int A, int B, A equals 7. No, whoa, let's make it 42 today. Yes, you know why? Thank you. The answer to life, the universe, and everything. Please go read your sci-fi. It's absolutely essential in computer science. Now let's look at this, because this looks quite familiar to the whole reference. Yeah, it's the same kind of thing we did with pictures just now. let's draw the memory. The moment I say int A, what happens in memory? I get a place in memory, which is now empty and is big enough to hold an integer. If I do this, now I get a B, which is big enough to hold an integer, nothing in it. Now I say assign the value 42 to A. So go to A, write 42, the value of 42. If I do this, what does this assignment mean? This assignment means take the value in A, which is 42, and copy it to B. So both become 42. Het ek nou verkeerd geskryf? Dis mos reg. So now, if I change B, I change B. If I change A, I change A. So if I now say A is actually 31, the first uninteresting number, I get a 31 there, but B stays the same. Over here, you have to remember when you change an object, you can change the values of an object only through the supplied instance methods. If you do it like this, you're changing the reference, not the object. Draw it in memory and see what you're doing. If I wanted to change the value of A, yes, I can use the instance method to do it. If I have the name of that thing, A or B, if I simply use that without specifying an instance method, I'm working with the references. Here I'm working with the references. So now it works like a primitive type, like int. It copies the value. Yes? So B equals A means take the value in A and copy it to B, just like integers. And if I want to change the value of in the object itself, I have to use the instance methods. Draw the memory. Okay? Because you're going to get mightily confused. Okay. Let's move on. Immutable types. Some things I do not want to change. Yes? It's a bit like constants in a Java program. If I declare a constant max value at the top of my program and I never change max value, Java doesn't have this. Other programming languages actually allow you to declare something as a constant and then you cannot use it you cannot assign new values to it. Okay? So the value cannot change. For example, if you use the Java color object, clearly you cannot go willy-nilly in your client application and change the definitions of the colors. So color is an immutable object. The value cannot change. Immutable means the value cannot change. Mutable means the value can change. But now there's something which you need to do for homework. The book claims that string objects are immutable. Google this. Find out why that is correct. Of course I can assign values to a string. Of course I can change the value of a string. But now the book says string is immutable. Go find out why. Okay? Comparing objects. Please, 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 please. Comparison with the double equals, yes, works on primitive types. If I use reference types, yes, like A and B and C, I cannot do this because this double equals is comparing the references. So if I have A, which is a reference, B, which is a reference, and then I make a another reference, C, which also points to B. Yes. Then B equals C is true and A equals B is false, but you're comparing the references, not the values in the object. Okay? So if you're using objects, you always have to use the equals method. Because then the equals method will follow the reference to the values and compare the values, not the references. Okay. Arguments. What happens if I have a method and I want to send an object as a parameter? You know that Java uses parse by value. Do you know what that is? Do you know what it means? Have you done that specifically in the first semester? That comes from being able to program but not doing the theory. Okay, yes. I really like Prof. Geldenhuys, but we have quite different ideas. Okay. Scope. Every time, no. E-mail, maandagoggend herinner my, ek gaan dit in detail doen. I'll do this in detail. On Monday, just going through. Normally when you send an argument over to a method, a static method, and if I change, suppose I send X. From my main, I have the method A, and I'm sending X over, which is an int. Now, method A can change the value of X, but that won't reflect in main again. Yes? You know that. Weet julle waarvan ek praat? Een weet my, ek vertrou jou nou nie meer nie. Miss January, do you know what I'm talking about? Thank you. I will do this in detail on Monday. Okay? So then I'll come back to parse by value again. The point being, if I parse a value, if I parse an object, I'm parsing the reference, but let's go through that in detail. The last thing I need to mention is arrays of objects. Haha. I promised you that if you have an object, you can do anything to it that you could have done with primitive types. So therefore, I can have an array of objects. Be careful when you instantiate, because look at this code. You remember good old charge? So suppose I want an array of charges, yes? And then I knew. This is a new for the array, not for the objects in the array. So if I do this, I still have to new every array element as well. Okay? So be careful how you use that. This first new is just for the array. It does not instantiate any of the charge objects inside the array. Okay? Makes sense if you think about it. Draw the memory. If you don't understand this, draw the memory. See what happens. Okay. Now, my good old manipulating references. What can happen if I have objects and now I'm very clever and I'm assigning references? Yes, like this. It can happen. I have an A and I have a B. No, this is B and this is A. If I now say B equals A, there's no way that I can get to these values again because the reference to this object is lost. I just overwrote it with that assignment. So there is no reference anymore to B. This is known as an orphaned object. The only way I overwrote the existing value, so I cannot get to this memory address again. If you do this enough, times you get lots of memory that are not usable, that are not accessible, and they're just hanging there. So you're filling up your memory and you run out of memory, also known as a memory leak. Okay? And Java has something called garbage collection. Periodically, it compares the references available in your running program versus memory. And if it finds that they are orphaned objects, it makes it available for reuse. I will start Monday morning with these 5 pages again because it's very important. Okay, great. I'll see you on Monday in this room. Okay, 11 o'clock.